Let's work through some examples of magnification calculations. This is one way that you could be asked a question about magnification. You're given a picture of some cells and you're told that the actual size of one cell is 0.1 millimeter. So you need to know two pieces of information to calculate the magnification of this image. So you need to measure the actual image size. So that's the size of the drawing. And you can see from this ruler that the size of the drawing is 2.6 centimeters. So when you're doing this calculation, first of all, you need to make sure that you understand that 2.6 centimeters is actually the same as 26 millimeters. So we want all the units to be the same so that you can do your calculations correctly. And now we're going to take the image size, so the drawing size of 26, and we're going to divide it by the actual size, so the life size of the cell, which you're told in the question is 0.1. Both in the same units, they're both millimeters, so when you take 26 and divide it by 0.1, you get a magnification of 260. So you write 260 and you put an X for times, 260 times bigger. The next way that you can be asked about this is to be asked to calculate the magnification of this drawing, and this is an electron microscope drawing, and it's an image of a mitochondria. This time we've got a scale bar, so we don't actually have to interact with the main image itself. We can use the information we've got on the scale bar. So you can see on the scale bar that the actual size of the length of that bar is 1 micrometer. And when we take a ruler to the drawing, the image size is 4 centimeters. So 1 micrometer in real life is being represented by 4 centimeters on the drawing. So let's put them into the same units. So 4 centimeters is the same as 40 millimeters. And now we need to times it by 1,000 to work out how many micrometers there are. So it's 40 times 1,000, so 40,000 micrometers. We use our formula and we put the image size, so that's 40,000. On top of the actual size, which was 1, and that means that our magnification equals 40,000 over 1, so our magnification in this example is 40,000 times bigger. And always when you finish the calculation, check that it makes sense. Does it make sense that an electron micrograph image would be 40,000 times bigger than real life? Yes, that sounds about right. So this is the way you may also see a calculation where they give you an image and they tell you the magnification, but they want to know the actual size of something within the image. So in this case, you're being asked to work out the actual size of the nucleus. So it's another electron microscope image. Let's have a look what we can do with this. So we know the magnification. We can use our ruler to find out the width of the nucleus. So the image size is 10 centimeters. We have enough information now to work out the actual size. So we're expecting the answer to be in micrometers because it's things within a cell. So let's turn 10 centimeters into micrometers. So 10 centimeters, times it by 10 to get it into millimeters, and then you times it by 1,000 to get it into micrometers. So it's going to be 10 with a 0 for times 10, and then 3 extra zeros for times 1,000. So 10 centimeters is the same as 100,000 micrometers. So that's I, our image size. We know the magnification. So to work out the actual size, we take the 100,000 and we divide it by the magnification. So in this case it's 15,000 because it's an electron micrograph. It's going to be a big number there. And when you do that calculation, you end up with the answer of 6.67. The units will be micrometers because we've already done the conversion. And that is the width of our nucleus. And then you think, does that make sense? Yes, that makes sense.